right, everybody, welcome. Come on in. Sit down and have a seat. It's going to be fine. It'll be okay. It won't be the worst thing you've done today, maybe. So have a seat. Come on in. Get comfortable while you're up. While you're milling about. Please grab that code up there at the top. I'm a big believer that if you're among the 4 or so billion people on the planet that are already connected to the internet, that code is the single most powerful thing you can do to affect change. Naturally, that leaves a balance of 3 and some change billion people who don't have access to the internet, but still 1 billion at a time. Okay, we're going to get there. So code first. I love code. Code is how we should talk about code instead of slides about code, right? So there's that. Also, I'm on the internet. I'm happy to carry this discussion forward beyond the constraints of our humble time together. So please don't hesitate to reach out to me on the internet there. So that's my, oh yeah. All right, good stuff. Money. Don't hesitate to reach out to me there at that Twitter handle. I'm on the internet. I want to talk to you there if you don't mind. Also email. So how many of you have Twitter? Twitter. It's 2016. Twitter. Anybody? Okay. Awkward. What about email? Email. Anybody at all? No. Okay. Well, if you have either of those social networks, as the kids call them, please don't hesitate to find me there. I'm happy to carry this discussion forward. Now, a little bit about me. My name is Josh Long. Thanks so much, very much for coming. I'm a Spring developer advocate on the Spring team at Pivotal. I'm an open source contributor and a hacker. #1, top ranked, 7 years running. #1 contributor of bugs, but still, #1, 2 projects like Spring Boot, Spring Cloud, Spring Integration, Spring Batch, VOD, and Time Leaf Activity. More bugs per any commit than anybody else in the world. #1, top ranked, 7 years. I'm also a Java champion. That means I spend a lot of time before audiences like yourselves and customers and community members and so on, doing my level-headed best to help them win with Java. So as part of that, I write books and I do video training series. That book, by the by, for those of you wondering, and I know you are, that's the latest and greatest book I'm working on. It's got the blue-eared kingfisher. The blue-eared kingfisher from the Javanesian island. So it's a bird, you see, that from Java. So it's a bird in the clouds. They fly. Bird, Java. No. You'll get it. It'll come. Don't worry. We had to work hard to get that bird. I mean, the book's not going to be great, but the bird, people remember that, you know. All right. And I work at Pivotal. And Pivotal is a small company with big dreams. We have lots of great open source stuff. And while we do care about open source stuff, it is not the reason we're here. It's not our raison d'être. It's not the thing that motivates us every morning before, as we get to work. It's not at all. We love it, but it's not the reason. We care instead about helping users, community members, and customers move quickly and safely from concept to production. And we know that a lot of organizations struggle with this, particularly those that have been around for longer than 10 years, before the era of cloud computing and the economics that were so manifest in cloud computing were, made apparent to everybody. This has meant that a lot of organizations have software that predates cloud computing. It predates the economics of cloud computing. Ooh, hi, love that guy. So these applications are hostile. You see, they have these existing applications that while well designed for the time in which they were conceived, don't particularly lend themselves to agile iteration today. These large existing applications are unbroken. They're large, require lots of people to make changes, to test, to develop, to iterate upon, right? It takes a lot of people to move the Titanic, so to speak. And so while these applications have served us well, they represent a bit of an obstacle today. Organizations understand that they need to go fast, but they have this existing large application that's hostile to being maneuvered and changed and iterated on. So they look for ways to go faster. They understand that speed's a differentiator, right? I don't have to look too far for supporting evidence of this. What is the #1 taxi company in the world right now? Thank you, Uber. What is the #1 hotel company in the world right now? What is the #1 video rental service in the world today right now? And what is the #1 in terms of year-over-year growth car company? What? No, it could be Tesla, right? These are all organizations that, when they started, didn't have more money, more resources, or more brain trust, or more people, or more anything than the incumbent competition. They had one thing and one thing only: the agility, the element of agility, right? That gave them a differentiating secret sauce. And so these organizations have kind of proved what you can do if you're able to make mistakes, try them out, fix them, and then go faster than the rest of them. You don't have to be more intelligent or anything. You just go faster. And so organizations today understand that they need to have that same speed, and they try and optimize their process. They know that work proceeds from product management to user experience, to developers, to testers, to administrators, etc. They try and optimize parts of it. They say, oh, well, maybe the developers would do pair programming and TDD. The administrators will use a cloud computing technology like Cloud Foundry. And that helps a little bit, but you still see slow movement through that whole workflow, through that value chain. And the reason is because each piece that you're moving through that value chain is huge, and it requires a lot of people to test and iterate and stabilize. So instead, organizations look for small batches of work. They turn to Dr. Eric Evans in his amazing book, Domain-Driven Design, in which he talks about the idea of a bounded context, a part of the domain model that, when extracted from the larger whole, stands unto itself, internally consistent and reusable. A bounded context is a nice candidate because it's small, usually, if it's truly bounded, and it's easy to have a small group of people focus on. A small group of people that focus on a small, internally consistent, reusable, independently deployable, bounded context. What we're talking about is a microservice. A microservice is a unit of organizational agility. It helps you solve the biggest constraint you're likely to have in an organization. How do I get my people to move faster? If you find that you're spending more time in meetings talking about what you're going to do versus actually doing it, you might need to move to microservices. It will also help you scale out better than any other approach and architecture right now, but that's not the reason you should go to it. You are not, as far as I know, Google or Netflix. You don't have their scale problems. You have organizational scale problems, and you're going to hit that a lot sooner than you're ever going to hit Google scale problems. And if you move to this architecture, you have pain that you have to address, and you have to address it quickly. The first pain is, of course, you have to have the ability to stand up new services quickly and safely and consistently. Most organizations have what I refer to as the dreaded wiki page, the wiki page with 500 easy steps to production. That wiki page is the enemy of velocity, and we need to go fast, and we need to get past that list of non-functional requirements that gate our movement to production. The second thing you're going to have to address quickly is how to solve the implied complexity when you move to a distributed systems world, because if there's anything upon which I'm sure we can all agree, it's that distributed systems are hard. So, for that, we're going to look at, to solve the first problem, we're going to look at something called Spring Boot ever so briefly. How many of you have played with, used, or seen Spring Boot? Okay, so I'm going to go super quick, and then we're going to look at Spring Cloud as a way of solving the second problem. Now, this is my favorite place on the internet after production. So I love production. You should love production. You should bring the family. It's great this time of year. The weather's nice. It's the happiest place on earth. It's better than Disneyland. Production for the win, okay? But if you're not already in production, you can start your journey there with start.spring.io. If you want for inspiration in your early morning, before your cup of coffee or chai, start.spring.io. If your children are restless and can't sleep, start.spring.io. And if you suffer from indigestion and seek relief, start.spring.io. We're going to go ahead and build a very, very simple service, and I don't care all that much about the domain model of the service. I just want to have something with which we can play and iterate upon. So I'm going to call it the reservation service. I'm going to bring in Spring's web support. I'm going to use H2, which is an in-memory embedded SQL database. And because it's an embedded database, it loses all of its state every single time you restart. So in that way, it's very much like MongoDB. We're going to use that. We're going to use JPA because I make poor life decisions. So JPA. We're going to bring in the Actuator support. We're going to bring in distributed tracing support with Zipkin. We're going to bring in RabbitMQ stream processing support. We're going to bring in REST repository support. We're going to bring in stream processing. Do I already have that, Rabbit? Oh, I did already have that, Rabbit stream. We're going to bring in Eureka for service registration and discovery and the config client. And then we're going to hit generate. Now, naturally, we could elect to go down here and switch to the full version. And if we do, we're going to be given a veritable plethora of options, checkboxes, things that you could do beyond what we've just done. And you can peruse these at your own leisure later on. How many of you remember those ridiculous ads from Apple? There's an app for that? Anybody? Screw that. There's a checkbox for that. Okay? Now, here you have choices, and a lot of people, if you want to choose a different language, be my guest. That's a great place to exercise some discretion. Any language in the JVM, Scala, Kotlin, Java, Groovy, whatever, all of them work just fine. That support annotations and objects. But then here you have non-choices. These are choices that you could make in the same way that stripping naked and running in traffic is a choice. You could, but don't. Don't. So, for example, Which version of the JVM would you like to use? Would you like to use the current one from the future? Or would you like to use yesteryear's stuff? And since both of these are end-of-lifed, that's a terrible idea, right? Use the new stuff. Use the good stuff. Otherwise, Richard will cry. We don't want Richard to cry. And then the choice of packaging. And a lot of people get confused about this. They don't know when and where to choose which option. So I'm going to do my level-headed best right now to explain when and where to choose which. Should you find yourself, by some freak fluke of physics, far, far, far in the distant past, long, long away from modern help, then absolutely choose .war. But if you're here with me in 2016, then choose .jar. This is a big part of my overarching, guiding, personal philosophy of make jar, not war. And again, you have choices. You have options. You should do what works for you, which happens to, in this case, coincide with what I tell you to do. Okay? So I've generated a service. Oops, it seems I've already got a whole bunch of other stuff. Excuse me. Goodbye. Generate again. We'll open this up. I'm going to clear my voice louder and prouder. We're going to open up our IDE, and it doesn't really matter which IDE you use. How many of you use NetBeans? It's good stuff. Hot sauce. Spring Boot tools for NetBeans. What about in Eclipse? Good stuff as well. What about IntelliJ? How many of you are using IntelliJ? Whoa! It's certainly the majority at this point. All of them are just fine. Use whatever you want. What about Emacs? Are you here, sir? Are you here? Oh, there he is. It's the same guy. He goes to every talk I do in every continent, in every country, in every city, just to raise his hand, and then he leaves, usually. Right after he says, I use Emacs. Troll. Whatever. So, I'm going to go ahead and build a very, very simple domain model. Can you see that code in the back? Raise your hands if you can. Yeah? Okay, good. So we're going to build a very simple domain model. I don't care too much about the scope of the domain. I want to have a simple object called a reservation that's going to have a primary key. It'll have an auto-incrementing unique value, which I'll signal here using the @idea annotations from JPA and the generated value annotations. It's going to have a field that's going to be written to a database column called reservation name, like this. And it's going to have a JPA entity annotation, which tells JPA to manage it for us. Now this, my friends, is the purest, cleanest, most concise expression of our domain. It's beautiful, if you'll agree. But it's not nearly enough. It's Java. So more constructors. Okay. A toString, some getters. Okay. Come on, computer. You can do this. There we are. And we need to make short work of reading and writing and working with that repository. So we're going to create a JPA repository that, working with that entity rather. So we're going to create a repository that makes short work of the common soul-annihilatingly boring creation, reading, updating, and deleting. Now, I want to make this a RESTful service. So I'll say REST repository resource. There we are. And then I'm going to go ahead and insert some sample data. So I'll say sample CLR implements command line runner. And command line runner is a callback interface in Spring Boot. Whenever Spring Boot sees the void run method on the command line runner interface, it calls it, passing in public static void main string args. So you have an enviable place to start your batch processing, integration, all that kind of stuff. And in this case, we can do some initialization. So I'm going to tell Spring to provide the right object. Now this is the correct way to do this. Always do this. Use a constructor. Prefer constructors at all costs. The wrong way to do this is to do this. That's called setter or field injection. Every single time you do this, a unit test dies. Every time. So don't. Okay? Now, I'm going to create some sample data here. I'm going to say stream.of. Come on. That didn't go well at all. Stream.of. My name's Josh. Nice to meet you. Richard. What's your name, boss? Steve. Hey, Steve. And what about you, buddy? John. John. And you right behind him, miss. Spell it? Roxanna. Yeah. Lovely to meet you as well. That's 4, 5. I need 3 more. I won't be able to sleep at night. What about you, miss? Nadia. How do you spell it? Navia. Navia? Ne. I'm sorry. Okay. Like that? Yes. Okay. Thank you very much. Nice to meet you. What about you, buddy? Kaushik. How do you spell it, my friend? Kaushik. Like that? Yep. Groovy. Nice to meet you. And what about you right behind? Cool. Is that okay? Good stuff. Thank you. So I'm going to visit everyone using a lambda. That's a nice feature that came from the future that only other very modern languages like C, COBOL, Perl, Smalltalk, Lisp, etc. have. So as a Java champion, I'm very proud to talk about something we added 2.5 years ago now. Here we go. And that should do. If we run this application, we should see a REST API spring to life, pardon the pun, on port 8080/reservations when it starts. Now, I've already loaded it to the gills with dependencies, so now is an ideal time for me to take a swig of water. Oh, Santa Maria. Okay, there we are. Look at that. Good stuff. It worked. It worked. Of course it worked. It was a demo. It was always going to work. One thing that people don't take time to appreciate is how well it worked. And while I care about that, it's not really what I wanted to talk to you about. I did want to show you this. This is the ASCII artwork in Spring Boot. I'm a big fan. A lot of people, I'm a big fan of IntelliJ, obviously, but I got to tell you, I found a fairly serious deficiency in the JetBrains IntelliJ product, something I thought we could talk about right here and now, something I never really quite understood. What the hell? Why is that there? That's a dumb feature. Now, I did what all adults do in the modern age when confronted with adversity and challenge. I went on the internet and I complained and cried loudly. And I was greeted by a message of hope from my friend Jan Sebron, who's on the IntelliJ JetBrains team. He's a software developer by passion, whatever that means. Okay? And he shared this message with me, which I relay here for you today. A message of hope. Don't worry, my friends, we're going to make IntelliJ great again. It's going to be awesome. Anyway, moving on. So now we've got a REST API, we've got data in the database. Can I configure this? Can I change things? Well, of course. I might go to application at properties, and there I could specify all sorts of things, like, for example, the port. And that's certainly one option, but if I did that, I'd have to recompile the application each time. I need to support 12-factor style configuration, which is the idea that environment-unique specific information should be kept, guess where? In the environment, away from the actual compiled code. So I'm going to go here. I'll say downloads reservation service, and I see in my directory here that, oops, I'm going to go down, Maven clean install, and I'm going to skip test because YOLO. So here we go. And that's going to create a jar for me. And here's my jar, or not. There's my jar. And you can see it's got everything I need, and I can run it very simply, java-jar, reservation service.jar, and there we are. Or I can override bits of it. So suppose I wanted to set the server port. I could do -d server.port equals 8010. Right? That's one way to override the built-in property. I could also use environment variables. I could say export server _ port equals 8030, and then do java-jar reservation service.jar. And while this is pretty interesting and useful in of itself, I think you'll agree that it's going to fall short for some pretty critical use cases. Oops, hey, come here. There's 8030, right? It's going to fall short for some critical use cases. So suppose I wanted to centralize all my configuration. I didn't want to copy and paste it from one service to another. How would I solve that? What if I wanted to handle symmetric encryption and decryption of passwords that were at rest in the property file? How would I support that as well? And then what if I wanted to change configuration live while the service is running instead of having to restart it just to change the environment variables? How do I solve that? And then finally, how do I support auditing and journaling? How do I see who changed what and when, and if necessary, to roll back that change? So for all of these use cases and more, well, I'm sure we can imagine a way forward, given this stuff as a basis. It is work that we don't need or want to do. It's work that we have to do in the interest of a better application, but it's not going to advance our lot in the marketplace or make us a better competitor, etc. So instead, let's go back to start.spring.io here, and we're going to build something called a config server, which is going to be a REST API that sits in front of a directory full of configuration and acts as the middleman, or middle service in this case, between our clients, our microservices, and that configuration. Now this configuration has to be managed by Git. So you can use, a GitHub repository if you like, or GitLab, or you can even just clone it locally and use that. As long as it's a valid Git repository, Spring Cloud's config server doesn't care. So I'll say config. Oh, could you hear that? Yeah? Oh, that's so good. Merry Christmas. Anyway, config, there we are, a bunch of property files. I want my microservices to be able to consume these property files. So let's look at how we're going to do that. Here's the config server. We're going to make this @enable config server, like that. And we're going to specify in the properties where to find the directory full of configuration. And of course, in my machine, it's on my local machine, on my home directory, on the desktop in the config directory. And we're going to also pin this application to server.port equals 8888. Okay? So suppose I am a microservice called the reservation-service, and I want to get configuration from the config server. What information would I see? If I go to the reservation-service.properties, click on that, you can see there's properties here, right? So let's see what that looks like if I visit the config server. The config server, localhost 8888 reservation-service, has a port, 8000, and a message. And we have application.properties. So all microservices, no matter what their name, will see this information. Only the microservice called reservation-service will see this information. Should there be a conflict, then the more specifically named file, this one, overrides the default. So let's change our application to spin up on port 8000 and to use this silly message that we've got in our property file. Okay, so here's the reservation service. Let's go back to the build and make sure we've got the Spring Cloud Starter config client. Okay, and here we're going to give our application a name. It's going to be called the reservation service. That way we know what config sets to load. And we need to point the microservice to the directory full of configuration, localhost, or to the service rather, the config server. This information is used by Spring Cloud early on to bootstrap the resolution of the rest of the configuration. So by convention, Spring Cloud expects this property file to be called, guess what, bootstrap.properties. So we'll rename it accordingly to bootstrap.properties, okay, like that. And now we should, if everything goes to plan, see this application spin up on port 8000. And I also want to use that message that we've created. So I'll say private final string message. And I'll create a constructor here, and I'll inject the value there as part of the constructor. And I'll say at value, $message, curly bracket. And I'm going to create an endpoint here that says I want to respond to an HTTP GET. And whenever somebody goes to localhost 8000, they should be able to read this message. Now, the thing is, this message may change. You saw the message. It's good, but it's not really great, is it? We can do better. So I'm going to go ahead and make this bean refreshable so that I can change that value live without restarting the service. So let's go ahead and see that in action. Now, when we see this start up, we should see two things. Port 8000, we established that, and then also the message endpoint. Okay, localhost 8000 reservations. Come on, computer. There we are. Message. There's our message. It's good, but it's not really great. So we're going to revisit the directory here. Reservation service.properties. Hello, devops, UK. Extra exclamation mark. So it's to reinforce my credentials, authority, and authenticity on Reddit. Okay. Git commit -a -m YOLO. Now, here's our config server. It sees the new value immediately. No problems. It understood what just happened. But our downstream service has no idea yet of what just happened. We need to tell it to refresh its own configuration. We can do this a few ways. We can connect it to an event bus, and then whenever there's a message, all connected microservices see the change. Or we can use the Actuator Endpoint. Now, Actuator and Spring Boot are a set of endpoints that expose information about the services. So, for example, metrics tells me the host and the memory and the uptime and heap and non-heap and all that stuff about my application. There's another endpoint called refresh, which you can call with an empty HTTP post like this. Okay, localhost 8000 refresh. Now I'm going to move that up here, move this down there. We're going to localhost 8000 message. Okay, so now ready, go, refresh. So I changed the object in situ. I didn't have to restart the process, and I was able to get the values immediately. This is a feature flag, in effect. It's very useful because now I've decoupled the release of software from the deployment of that software. I don't have to activate features. In fact, I can hide things in action. I can support canary tests and A/B testing. I can even do continuous delivery better, because the goal in continuous delivery is to have a pipeline through which all code eventually passes and then gets, hopefully, into production. The implication, one of the things that makes that work is you have constant integration, so you're constantly contributing to master. And if you're working on something that is logically larger than one day's worth of work, then you want that code in master, but not in everybody's face causing trouble because it's not ready yet. To support that, you can use branch by abstraction. You hide the feature and turn it off with a Boolean, which you can do with this, for example, property file, right? So continuous delivery has been shown to increase people's productivity, make them happier, help them work less time, give them better personal lives. So what I'm trying to say is Spring will make you happy. That's kind of what I hope you grab from this moment, okay? Now moving on. The next thing I need to care about is the ability for one service to talk to another service with ease and abstractness. I want one service to not worry too much about where another service is located, on which host and port. And at first blush, this might seem a use case for DNS, but DNS is kind of a poor fit in several different situations. How do I, DNS is, first of all, designed to be cached. Second of all, it doesn't have the ability to answer very existential questions, like, is anybody out there? If I make this request, am I going to block waiting for a reply, or is there something actually out there able to reply? I cannot answer that question because I don't know what the system looks like. And I also want to be able to support client-side load balancing. I want to be able to handle the routing decisions on the client instead of at some sort of F5 server or load balancer, because my client is in a better position to make that decision. So I'm going to use a service registry. A service registry is like a phone book for the cloud. There are many different implementations out there, but I'm going to use Eureka. You can use Apache Zookeeper or HashiCorp Console or whatever, but I happen to be a big fan of Eureka, first of all, because it's been used for many years at scale by one of the biggest websites in the world, and then second of all, it's dead simple to set up, and I am, if nothing else, exceedingly lazy. So there's that, okay? We have an abstraction called the Discovery Client Abstraction that you can use to talk to different, come on, Eureka service, there you go. To talk to different implementations of the different service registries, rather. So enable Eureka server, application.properties, Spring Cloud config .uri equals HTTP localhost 8,000 even, spring.application name is equal to Eureka service. I'm going to rename this property file to be bootstrap.properties, not striap, okay? And go. So that should, if everything goes to plan, spin up on port 8761. But our service won't be among the registered instances, at least not yet. We need to tell our reservation service to raise its hand and say, if anybody needs me, I'm here. This is my host. This is my port. Right? So we're going to use the Spring Cloud Starter Eureka dependency. This is the Discovery Client Abstraction implementation for this particular registry. There are others, and they all have the same base contract, Discovery Client. So let's see. Localhost 8761. Come on, computer. Did I? Uh-oh. Spring Cloud configure. Son of a motherless goat. Thank you, my mob programmers. You guys are great. This is why pair osmosis is awesome, and it's a thing. Okay. We may have a race here. A race to the bottom. So there's this. First thing to notice. Good quality animated GIF. Took a long time. Did our service register yet? It's up and running for one of time. I'm going to restart. And so we're going to have a service here in just a second that will be registered and available for consumption by another service, which we're going to build. We're going to build a client called the reservation client. And we're going to bring in the config client and Eureka service registration discovery, REST repository support, Zool, the microproxy, Hystrix, a circuit breaker, Zipkin for distributed tracing, and RabbitMQ for stream processing. It's going to be fine. We're going to open up this client, and this client is going to be an edge service. It's going to be just that. It's going to be a component that sits at the logical edge of your architecture, responding to requests from a field, from outside, your iPhones, your iPads, your PlayStations, your Rokus, your Xboxes, your smart TVs, your whatever. In the industrial internet and Internet of Things, it could be your refrigerator, you know? So these are client-specific concerns, and want to centralize them in one place. They act as the logical door between the outside world and all of your microservices. They will be exposed via DNS, right? Obviously, your iPhone isn't going to use Eureka. They're going to talk to the service normally through DNS, but then it's going to do any kind of payload or protocol or security sort of translation, enrichment, and mediation, etc. So let's make sure everything's fine back here on the Eureka Ranch. There we go. There's our reservation service. There's our one instance. It's got one instance at this IP, this service ID, and this port. It's available. And we've created a reservation client, and we need to do the normal sort of pro forma boilerplate kind of stuff. So Spring Cloud config URI equals HTTP localhost 8888, spring.application name equals reservation-client. And, of course, this has to be renamed bootstrap.properties. Okay? Bootstrap, yep, that's fine. and we're going to look at the reservation client. We're going to participate in service registration and discovery. Now, think about your average clients, right? Even the most boring and conservative of organizations has an iPhone, an Android, and an HTML5 experience. Most have more, but there's at least those three you've got to worry about today, right? You can't go to market missing mobile, for example. That's craziness. So you have to care about the security concerns and the constraints and the protocol concerns for all these environments. Think about HTML5. HTML5 browser environments are not typically bandwidth constrained. They have a lot of power. You don't need to hold their hand. Have you ever seen JS Linux? JS Linux. This is ridiculous. Just pure, straight up ridiculous. This is JavaScript that's downloading an ISO for Linux and then evaluating it in the browser. It's running the x86 executable in the browser. So tell me again why you need to do a native desktop app? Yeah, I didn't think so. So the point is, HTML5 clients are super useful. They can do all sorts of good stuff. You don't need to hold their hand. But they live in a sandbox, unable to reach across the network partition and talk to other things in different hosts and ports. They have a single origin policy, like coffee. The important thing is that we want to add access to these different microservices, but we don't want to have to retrofit every single one of these microservices to be aware of what's just happened. I don't want to have to add an XML policy permitting cross-origin requests to each microservice. So instead, I'm going to proxy those requests through a specific kind of edge service called a microproxy, which is like this. I'm going to use Zool. Now, I'm not sure if you've been keeping up with your Ghostbusters and Greek mythology, but Zool is the gatekeeper to Hades, hell, L'Inferno. Now, that's what I thought at least. And then my friend said, you know, Josh, that's not fair. We don't know that. He could come from a very nice place, maybe Hawaii. Who knows? So it's not fair to judge, and I'm sorry. Anyway, he comes from somewhere, and he's the gatekeeper to that somewhere, right? I'm not sure if it's ever spelled out in the movie. And Zool is the microproxy that we're going to use, named for him, or it, okay? And Spring Cloud, along with the discovery client, will automatically set up routes for us based on the service IDs. So I can access all of the services that have been registered in my registry from the same host and port. I've got this application running on port 9999. You can tell because it says 9999. Now, I can go here to reservation-service/reservations to access the data from my reservation service. Notice this is localhost 9999 reservation service, and then we've got the original service here, the first and still the best. Okay, so there's the actual service. There's the edge service. Actual service, edge service. Actual service, edge service. Actual service, edge service. Right. You notice that there's the same data from the perspective of the client. There's no reason to indicate. There's nothing to indicate that this service, this data, was produced on anything but that node. The proxy sends a request to the downstream service via some URL that it resolved from the registry, and it sends a header saying that this is my current origin URL. So the downstream service uses that and rewrites its URLs to look like it's coming from the right node. Right? The benefit, of course, now is that my HTML5 clients can access all of my services from one host and port. So, whoops. I could have R service or foo service or whatever. Point is, it's all there. I should absolutely, no questions asked, I'm not even going to debate it, use HTTPS, of course. I should probably use HTTP basic or OAuth, some sort of authentication mechanism, right? But maybe I'm done. Maybe that's enough. Maybe I can go home, right? My HTML5 clients now have access to all of the services, and assuming homogeneous REST sort of JSON-y type services, maybe that's enough. Maybe I'm done. One thing to understand before we move on, of course, is which node is it routing this to? Right now, I've only got one registered instance of that service in my registry. So it stands to reason that it's probably picking that one instance since it's the only one, right? But what if I had 10 or 100 or 7? How does it know to pick which one? There's a component in play called Netflix Ribbon, and we've automatically integrated it for you. Ribbon is a very, very fancy comparator. It does the microservices equivalent of eeny, meeny, miny, mo. You give it a collection of server instances as it would have read them from the registry, and it'll pick which node to route the request to. You can customize that object. By default, it's round robin, but you could have, for example, data center aware load balancing, where you say route to the current rack or data center and then to the failover to another data center. Or if you have something stateful, like you're streaming video, and you want to pin the OAuth token, the user with that authenticated OAuth token, you want to pin it to the same node where you're streaming video, right? You want to have session affinity, sort of, without actually having sessions. For all these reasons, you can do all sorts of cool stuff with the load balancer, but by default, it's doing round robin, so you get the same benefit you would if you had a big dumb F5 router or load balancer in the middle, right? But now it's an object. You can version control it. You can unit test it. You can evolve it as your business use cases demand. You have the flexibility in your code. So that's a microproxy. Another kind of edge service is called an API gateway. And we're going to build a very simple API gateway that just translates it takes all of the JSON from the downstream reservation service, strips away the strata of JSON around the names, and retains only the names. So we're going to say class reservation API gateway REST controller, because I am nothing if not succinct. So public collection of not even close. What is a collection factory? Collection of string names. And I'm going to root this entire endpoint at /reservation. So it'll be localhost 99.99/reservations. I'm going to create this endpoint. I'm going to map it to /name. So get value equals name. So whenever somebody wants to access this, they need only visit localhost 99.99/reservations/names, and they'll get this data. And we're going to call our downstream reservation service using the Spring Framework REST template. The REST template is a little object that helps make short work of common HTTP invocations, right? So there's that. I'm going to tell Spring to provide it via the constructor. Now, I want my REST template to be aware of load balancing. So I'm going to configure a REST template here, like I would. Okay. But I want to make sure that it has an interceptor that does the right thing when we use the registry and ribbon and so on. So I'm going to make it load balanced. And I'm going to say return this.rest template.exchange http:// reservation -service. This is not DNS. That's the service ID in Eureka. That part is going to be stripped out by the interceptor and then replaced by a ribbon resolved URL and so on. I'm going to make an HTTP GET call. I'm not going to send a body. And then finally, I need to tell the REST template what kind of data I want back. And what I would love with all my little heart to be able to say is give me a collection of Spring HotOS resources. Recall that this is a resource. It's an envelope object, this bit right here. This is an envelope object. It's part of the HotOS project, or Spring HotOS. HotOS is hypermedia as the engine of application state. It's the idea that every REST resource should have information enough for the client to be able to further manipulate that resource without any a priori knowledge. I want the payload and the links. I want to take it from JSON and back to a resource. So I'm going to do that here. And to understand why this doesn't work, we have to fix the obvious problem, first of all. I don't have the reservation type on my local machine. I could, of course, copy the one from the implementation, but that would unnecessarily leak implementation details, and it would couple my client's lifecycle to the development of the service, which is what I'm specifically trying to avoid. So I'm going to create a local client-side DTO. Naturally, you should use schema-friendly protocols or payloads that can be forward and backwards compatible, so you can change things and not break everything. I would refer you to this blog on using Google protocol buffers by one of my all-time favorite authors here for your own leisure later on. Okay. Now, that still doesn't work. And to understand that, you should talk to Richard. Or at least let's just talk about it together openly and just say that Java's generic type system isn't really good, right? So given a list of string x, new array list, right? What is the generic parameter for that list? And the answer is that there is none, right? It's not reified, it's gone. As far as Java is concerned at runtime, via reflection, this is just a list x equals new array list with no generic parameters. You can capture them through subtyping, right? Like this. And this will work. So if I actually have a list of string x equals new x, I can ask via reflection what your generic parameter is, and that will work. And if you understand that workaround, that you can capture this information by baking it into the parent-child hierarchy, then you know what we need to do. We need to capture through subtypes our generic information. This is called the type token hack pattern. Pattern. I get that wrong all the time. So I'm going to say a parameterized type reference of resources of reservation, PTR, equals new parameterized type reference, blah. And I have to implement that. I have to subclass it. If I fail to have that on the code, it's abstract and it fails to compile. But if I do that, everything's happy. So I can say, PTR, give me your Java lang reflect type. I pass that here to my last parameter. And what I get, my friends, is a REST template envelope object, like that. And I can ask the REST template envelope object for its payload, which in this case is reservations or resources of reservation. And then I'm going to say, give me your body, give me the content, stream over the content, map from reservation to reservation name, and then collect it all into a list that we're going to send back to the client like so. Now, let's see what that happens. Now, one thing we have to consider is that this may not work. This may blow chunks, go south, and we'll end up with a big fat Java stack trace in our iPhone experience. That's no way to run a railroad, my friends. We need to do better. We need to understand that in a sufficiently distributed system, things will fail. It's pointless and futile to try and optimize for the high availability of a single node. That goes out, that decreases to 0 eventually. Instead, optimize for time to remediation. How quickly can you get, from the perspective of the client, the service back online, whether it's through load balancing or starting a new service or doing something? We need to gracefully degrade in this case, right? So if we have 1 to n instances of this service, it's going to work fine, 1 or more. But if there are 0, it's going to blow chunks. So we want to gracefully degrade. Let's see what it looks like right now. Localhost, reservations, names, 99.99.99, okay? There it is. There's our list of names from the reservation names endpoint. That works for now. But if there are 0 instances of that service, we're going to have trouble, right? So we need to make sure that we gracefully degrade. High-performing organizations understand this, and they approach it appropriately. Google, for example, understands this fact very well. There are people that go to work every day in their Google bus and they're wearing their Google t-shirts, where they go to the Google cafeteria and talk to Google colleagues while checking their Google Mail and their Google phones. They will, no doubt, given the velocity with which they're Googling, spill some of the voluminous, crazy amounts of Google Kool-Aid on their Google t-shirts in such time that they may need to go to the Google laundromat. They may walk around the Google laundromat in their Google bathrobes, sequin-lined, of course. And then when they're done with that, they may decide it's time to get lunch, because after all, it's almost 2 in the afternoon, and they'll go back to the Google cafeteria and have Google gourmet food. And when they do that, they may then decide to get on a Google bus or Google bicycle or Google shuttle and go to the Google data centers, where they will find, completely unsurprising to them, given that they have more than 2 million servers deployed in data centers around the world, that some of their Google servers have Google died. And they don't care, because they didn't build their system to be sensitive to the loss of a single node. Same thing with Netflix. They have a suite of components called the Simian Army. These are basically little agents of chaos that they let loose in production on purpose. They do things like kill -9 processes and disks and partitions, block ports, and even something called Chaos Kong, which, as I talk to you about, it gives me goosebumps. It purposely kills a whole data center availability zone. It's terrifying. They do this during office hours because they want to make sure that their failover strategies work. They have a very mature mindset there. They say, you build it, you run it. You're an adult, you can use whatever technology you want, which, by the way, I think speaks volumes about why they chose Spring Cloud for a lot of their services at Netflix. Wink. Anyway, that's a very mature mindset. They say, you build it, you run it. Use whatever you want, but be prepared to get the phone call at 4 in the morning when it goes south. So they use the tools that make it easy to do the right thing in the face of failure, because it will happen. So what we want to do is gracefully degrade. So we want to have a circuit breaker. I'm going to use the Netflix Hystrix circuit breaker here. Circuit breaker. And I'll go down here and I'll create a fallback method. I'll say public collection of string fallback, and I'm just going to return an empty array list. You know, big websites will do this kind of thing all the time. They'll say, oh, well, you called the service, but it's not working right now. Here's some machine learned. You call the search engine service, for example. It's not working, but here's some machine learned fallback, machine learned recommendations from across the web. It's not what you wanted, but it's better than nothing, right? So that's there. Do I have everything else I need here? Yep, that's good. Reservation client, let's start that up. And we'll go to the reservation service. That's there. So we should be able to hit this endpoint, see it work, and then kill the downstream service and see it hesitate. The circuit breaker is a stateful component. It's going to monitor the traffic through that thing. If there's too much traffic, or if all the requests are failing and there's a risk of it not working, it'll force traffic to the fallback method directly. That gives our downstream service time to recover. Right? We want our downstream service time to recover. We all know that if service isn't working, you should refresh the browser more, right? Well, that doesn't work for distributed systems either. So we need to defeat that effect. So let's see. There's a happy path. Everything's great. Let's kill now the reservation service. Poor reservation service. Okay. And there, it's hesitating, it's stalling. Eventually, it'll time out, but it's stuttering. I can fix that. I can overwhelm it by forcing the circuit open, like Command R, Command R, Command R, Command R. There we go. Right? Now it went straight to the fallback. No hesitation. It doesn't time out or anything. It just goes to the fallback. Now, in the last 6 minutes, we're going to cover two huge things that could take 2 hours each. So the thing that we care about now is observability. We've talked about how to build a service that is a system that is able to survive and thrive at scale in an elastic cloud environment. And we've looked at one way, not all of them, but one way to embrace failure, to understand that failure will happen. We need now to have a visibility, right? The metrics and the actuator endpoints that I showed you support some of that visibility, but I want to be able to see systemic visibility. Remember, my system has emergent behavior that isn't always obvious when you look at each node and each host. Remember that the map is not the territory. What my architecture diagram says is very different from what's actually happening. So one thing I may want to do is I may want to see the flow of traffic through those different circuits. I can support that with this Hystrix dashboard. Okay, so hold your breath. This is going to be crazy.
What is Hystrix?
Well, Hystrix is the circuit breaker. Good question. That's the circuit breaker that I just used. Netflix is Hystrix. And so this is a dashboard that we can use to monitor those circuit breakers. Remember, those circuit breakers represent connective tissue between our services and other services, potentially third-party services, which we can't instrument and add monitoring to. So what we want is the ability to at least understand the potentially shaky service-to-service call, the site of that, and then see what's happening. So Spring application name, Hystrix dashboard. Okay, and we're going to rename this file to be bootstrap.properties. And we're going to open up this. I'm going to say @enable discovery client and @enable Hystrix dashboard. Okay, we'll restart this. The second thing we may want to do is to support distributed tracing, which in theory is very, very simple. I want to be able to add a correlation ID to every message that enters or exits my system anywhere, right? Via the microproxy, via RabbitMQ or Kafka or the Zool or Spring MVC or the REST template or any place where you can produce or can send a message. I want to have a unique ID that I can then correlate later on to see the flow of messages in the system. I have something on the class path called Sleuth. Sleuth is a distributed tracing framework from Spring Cloud. It's an abstraction, first and foremost. There's this. So now I just made a request, and you can see it already logging the service ID, the trace ID, and the span ID. A trace represents the aggregate journey of a message through the system, right? So from A to Z. A span represents each leg in the journey, from A to B, from B to C, from C to D, etc. So let's see, config, Eureka, discovery, generate, open. Now, what I want is to be able to visualize this information, because while it's good to have it in the logs, and I can easily forward that to something like Elasticsearch or Papertrail or Splunk, I would like to be able to have more visualization, more information about what's happening. So I'm going to set up a Zipkin server. We have people from Twitter, where Zipkin was developed and open sourced, who contribute to Spring Cloud. For that matter, we have people from Netflix who could develop and contribute to Spring Cloud. So that's cool. Zipkin-service, bootstrap.properties, go, go, go. Now, let's see. The Hystrix dashboard is on port 8010, Hystrix.html, and it is expecting a server-sent event heartbeat stream that is representative of all of the traffic going through each circuit breaker. We could, of course, use the Spring Cloud Turbine project to aggregate or multiplex all of those streams into one aggregate stream, but for now, we've only got one instance and one service, so let's just use that. Here's my Hystrix stream. It is a server-sent event stream, so it is never-ending. It's endless, like the number of bugs in my code. It's forever and ever. So do not, whatever you do, do not curl that endpoint. Now, what we're going to do, go to localhost 9999/reservations/names. As I make the requests on the left, you can see them reflected in the moving average on the right. We can see what's happening, right? I also want to show you what we're doing in the distributed tracing world. So 9411, whoops. Okay, so this is our Zipkin dashboard that we just created. It knows about our service and our client. It knows about where messages have entered and exited. I can click on this. I can hit find trace, and it shows me, oh, look, I made a request less than a minute ago. Great. It took 16 milliseconds for the whole request. The message started at HTTP reservation names. It went to that place. Then 14 milliseconds later, it went to reservations. It exited the reservation client to go to reservations, and then it entered the reservation service, and I can see that here. I can click on each one of these waterfall graph nodes to see the log sort of each message in the system, right? So I'm now able to see what's happening very, very quickly at a glance. Now, of course, what I should show you is that if you kill the reservation service and you drive traffic to this endpoint, eventually you'll see the circuit open. That's when it goes directly to the fallback. So, my friends, I'm sorry we didn't get to cover much today. I feel like maybe next time, if we had a little bit more time together, we could really make a difference. Today we just talked a little bit about stuff. And I'm a big fan of this stuff. I hope you saw some applications of some things that you may want to use someday somewhere. What do you think? Yes, no, maybe? Up, thumbs up? Okay, good stuff. I'm a big fan. Obviously, I'm standing here wearing my spring t-shirt, my spring underwear. Of course, I like this stuff. But I don't want you to take my word for it. There are other small mom-and-pop shops out there that have been using this stuff at scale for years now, right? There's a company in Los Gatos in California called Netflix, which uses Spring Cloud to build systems and build services. It's more than just the sum of its parts by far. It's a cohesive integration that they don't want to have to rebuild themselves. There's a small company in China called Alibaba. They did $14 billion in 24 hours last year. So there's that. Anyway, they use Spring Cloud, and we talk about web scale, but screw that, China scale, man. So there's also Baidu, which is an analytics company. They do 600 to 800 million requests a day from Chinese people all around the country. Again, Spring Cloud. Right? Not the only thing, certainly, but we're going to make a difference. Now, I appreciate your time. Thank you so much, my friends. If you want to follow me on Twitter, we're happy to talk there. Thank you. I'll take questions out in the hall. Cheers.